took 95 suspected unisexual females from Eagle Marsh and had them genotyped by Jim Bogart, who's the guru of this stuff, at least he was 10, 20 years ago, so that he could identify the genetic components of those salamanders. And so here's the putative species that it could come from. If it's a Jefferson salamander, for example, it's a J. Texanum, smallmouth, it's a T. If it's, I forget who this guy is. What? I'm forgetting who Embystoma laterale is. But this is the coding for the different species. 87 of those 95 had chromosomes from all three species. 6 had 4 sets of chromosomes. They had a double set of chromosomes from smallmouth salamanders, from Texanum. And 2, he wasn't sure. So how's that for weird?
So they're sharing the chromosomal material via their not real mating. That's how they're getting it.
Yes, sometime in the past,
okay.
There was kleptogenesis.
Okay.
And then over time, you get various combos of that.
The polyploid somewhere.
Yeah, right.
That are in beauty. Okay.
But they're not typically mating.
It's not the one that they just mated with last
Right.
week.
They're just using that guy.
And it doesn't put them at some sort of disadvantage to have, like, all the things?
Good question. The answer seems to be no. That would kill us, but it does not kill them. They can tolerate it. We can't handle triploidy and that kind of thing.
Is there, to what end do they do this? Is this a natural selection?
Well, that is the million-dollar question, is why are they doing this? All I can say about that is that what we find with any kind of a species that's parthenogenic, that just makes clones of itself, is if mom was successful, then the children are probably going to be successful, and that introduces the question of why do any animals mate? Because then you have the cost of making males. You lose half of your chromosomes because you have to use half the chromosomes from the male. There's all sorts of arguments against sexual reproduction, but the benefits of it outweigh it because you get diversity. And when you have diversity and adversity, you get survivors. With clones, if a disease learns how to attack that clone, it gets everybody. So there's a little why have sexual reproduction lesson. And that applies here, but it's a disadvantage for the males because they've then contributed their sperm for no benefit. So they think they've mated and they have not. So it's detrimental to them. So they are preferentially looking for females, but they're not perfectly selective. So if they can't find them, or if almost all the females in an area are all unisexuals, then they will be mating with them. So that's the only benefit I can say, is that cloning can work well until it doesn't. And then it's an abysmal failure. But after a while, they go back to the wetland and spend the rest of their life in the wetland. And here's a male adult. Now it's looking, it wasn't really paedomorphic because it was a heft. Now it's coming back. Now it has gills. But it changed, the shape of the tail changes. And now it's a fully aquatic version. And then they carry on in the water.
Why do they go out at all?
I think just to, wetlands are a place where you can grow quickly, but they're dangerous and they're often ephemeral. If you go out into the woods, then you can, it's maybe not as rich, but it's a lot safer and that kind of thing. And then you get bigger and then you go back.
Plus, it's a pretty mad color scheme.
Yeah,
So it kind of goes backwards,
compared to,
like
Well-
the axolotl.
yeah, with an axolotl, it's a one way, yeah, to the one that has the gills and that sort of thing. This one, yeah, it goes, kind of goes the other way and then comes back.
Yeah,
Yeah.
interesting.
Another family are the proteids. This includes the mud puppies. This is a relatively large salamander that is relatively uncommon, although it's more common, it's more distributed than it used to be because people would use it as bait, and then when they were done fishing they would let them go, and so there's populations of mud puppies. So you could have mud puppies in Indiana that are from Indiana, and you could have mud puppies in Indiana that were from Louisiana, but they kind of look the same. But it turns out that they're escapees. They lived to tell a tale. And then another cool species is the hellbender, and the family for them is the Cryptobranchidae. That just means their gills are difficult to see. But they rely on cutaneous respiration quite a bit as well, and they have this big wrinkly skin. Even their costal grooves don't look like costal grooves anymore, but they have a lot of surface area for gas exchange. And these are only in streams to the south, but at one point we're pretty sure that they only remained in the Blue River in Indiana. But now there's an active head starting program, and even now a breeding program because they figured out how to do that. And the Fort Wayne Children's Zoo helps with a breeding program where they raise the hellbenders till they're about that big, and then they take them and they let them go, and then they grow back up to this pretty impressive size. So this is the largest salamander in the United States. There's a couple of Asian species that are bigger, that basically you have a salamander you can carry around. But these are pretty big. But they're having some success figuring out how to bring them back.
You said they're that big when they put them back in the wild, or they?
Yeah, yep.
So they grow until,
So they started out like that, and they got them up to like that, and then they let them go
and then they got to be.
like that. Yeah,
May I make a comment?
yeah.
Later, we'll let you know, Dave Messman is going to be talking to the Advanced National Naturalist Group. And if you're interested in hearing about the hellbenders, it probably won't be till the fall, but we'll invite you and come and listen. We'll give you more information on that. Right?
Yeah, good. Yeah, so our local zoo takes an active conservation role with some species, and one of them is the hellbender. All right, so that's salamanders. So let's work with frogs and toads. Frogs are the anurans, and they have short, stout bodies as opposed to those elongate bodies. They have reduced vertebrae. They have 9 or fewer vertebrae, and if you think about yourself, you have a lot more than that. They have relatively large heads. That has to do with hopping, and also the fact that they eat stuff and they want a large opening on the front end. Elongated high limbs for jumping. An anterior attachment of the tongue. So when a toad gets a bug, it just kind of flops out its tongue and it sticks to the object and it brings it back. It doesn't shoot the tongue out like a plethodonid salamander does, which has a rear attachment. And it doesn't have any ribs. No ribs at all in a frog.
So all those cartoons of a frog getting that fly by shooting it out are incorrect. Like,
Yeah,
I
I'm
remember
trying to.
as kids' cartoons, there was always the
Yeah, there's like so that I can't think of one that would do that. There's chameleons and there's salamanders, but I can't think of frog.
Never watched one do it, careful.
So all of this stuff is about hopping. Yes, they have big back legs, and I don't really dwell on talking about them, except they have lots of segments which help them propel themselves, but they're basically really powerful. So that's how they get the jump. But the other interesting things are that have to do with a compact body. And if you think about any critter that hops or flies, it always has a compact body. You think about bats, birds, kangaroo rats, kangaroos, they all have a pretty compact body. And that's because if you have a floppy body and you jump, you don't translate that force into the movement in the direction you had intended to go. So it's the conservation of the force that for the jump. And if you're going to be compact, then ribs get in the way. They'd be all crunched against one another, so they've evolved to lose those. The vertebrae, having a long cylindrical body is no good. You want to have a compact body, and in the process they've lost the vertebrae, and the ones that they have are compressed. And they're anteroventrally compressed, which means front to back. Then they have this weird thing called a urostyle. If you think about a frog, you think about your image of a frog, and it has kind of a bump in the middle of its back, kind of sticking up. That's actually the front edge of the hips. So the sacroiliac joints are right here. They're not down here, they're up here. And what that does is add one more long segment, because if you have any kind of a leg structure which allows you to act like a whip, that allows you to push the mass on the end of the whip more. So you add segments, and that allows it to happen better. Without getting too complicated, that's the benefit. But in between, there's this third thing called a urostyle, and that's made out of tail vertebrae all fused together into like a stick. And so it forms a strut that stabilizes the hip. Then there's the elongated pelvis. That means that you can take, instead of attaching your muscles here, you can attach them up there. So all those things together make for a more powerful jump. And then the most confusing thing is the suprascapula. And that has to do with the other end of the jump, which is when you land. You can imagine anytime you become airborne, you want to be able to do well on the other side when you hit the ground again. And so one thing that I like to emphasize when I'm talking about vertebrates in general, but mammals in particular, is you think about your hips, your legs go into sockets and are firmly articulated with your hips. So you have that femoral connection there that's pretty solid. But when your shoulders, you can shrug your shoulders, you can move them around. You actually have no good quality articulation between your arm. Yeah, so you have a connection like that, but it's not like this. The best connection you have is your clavicle. So your clavicle attaches up here, and it attaches to your sternum, but even that has a lot of flexibility. But the benefit of that for the frog is that when the frog hits the ground, or when you do a push-up, you absorb the impact of that collision with the muscles that are around your shoulder blades. So it's like a suspension system. And the suprascapula adds area so you can do that even more. So it's a little esoteric, but that's what it's all about. Another cool thing with frogs is that they vocalize, and you can learn, like for an area like northeastern Indiana, you can learn all the species relatively easily, and then you can identify who's calling or who's there, based on their call. And there's a standard protocol that you go out 3 times a year because not all species breed at the same time, and you just listen. You can figure out who's there. And
Oh, sorry.
okay, so to make calls, what they do is they fill the vocal sac with air, and then they use muscles to press it back out, and depending on the design of the aperture of the vocal sac, the nasal cavity, and also internal structures in the head, and then also simply the size of the frog, you get different sounds. And they don't really involve the lungs in this.
Do both sexes make the noise or just
I think when it comes to like a reproductive call, just the males do that. I think there are some species of frog where the female makes some sounds, but typically not. And then the males use those to defend a spot at a wetland, like a little micro territory, and also to draw in females to say, "Hey, I'm here." All right, and I'll get into that a little bit more as we go. But the really big frogs in Indiana are the ranids, the ranidae, like bullfrogs. So here's a big bullfrog, and the ranidae is a family. The genus that was Rana became Lithobates because Rana was conserved in Europe, I think was what happened. But this happens all the time when they're trying to link a specific name to a specific group, and they learn more about things. They have to change the name because it doesn't make sense anymore. That's what scientific names are for, is to help with the classification. So the genus Lithobates includes our largest frogs. Bullfrogs and green frogs are interestingly distinct from many of the other frogs that I told you about because their tadpoles overwinter at least once. So they can't survive in an ephemeral wetland. They'll all die because there's no water. These guys will metamorphose in the second year, sometimes even in the third year. Other species like the leopard frog and the wood frog do it all in one season. Bullfrogs and sometimes other species, but pretty much bullfrogs, are invasive in that we have stabilized water levels in wetlands, so they're not wetlands anymore, and that allows bullfrogs to reproduce in them. And then the bullfrogs pretty much eat whatever they can fit in their mouths. And so you have states like Arizona that now have bullfrogs. There weren't bullfrogs there, but we put them there because we like bullfrogs to eat. Well, then the bullfrogs started eating all the other frogs and a lot of other organisms. So now states like Arizona have active eradication programs where they're trying to kill all the bullfrogs.
So they're native here.
But they're native here. The problem here is that we have stabilized the water levels of a lot of our wetlands, which allows the bullfrogs to invade locally, and that's also a problem. So here's a bullfrog, and I like to contrast the bullfrog with green frogs. And green frogs can be brown, bullfrogs can be brown. Both are pretty big. Bullfrogs can get bigger, but a lot of times they look about the same size. So how do you tell them apart? And the way you tell them apart is green frogs have this dorsolateral fold, and bullfrogs don't. So if you see a greenish-brown frog on the side of a pond, and you're wondering which it is, you check for that dorsolateral fold. Probably usually they're going to be green frogs anyway, but if you don't see that, then you have a bullfrog. The other thing that's cool about, at least for species in this genus, is that if the tympanum, the eardrum, is about the same size as the eye, it's a female. If it's bigger, it's a male. So there's a little fun fact. But you can actually look at them from far away and say, oh, that's a male or that's a female. They still might. They are male after all. Here's a tadpole. So they would be the length of your hand. But when they metamorphose, they get to be the size of a quarter because they resorb all of that material to make it through the metamorphic period and transform. Wood frogs are related. They're lithobates as well. Wood frogs are the most abundant frog in the woods around here. So if you're in any kind of a place where you have the wetlands that they need to breed, and you have not just a little tiny forest tract, but a reasonable amount of habitat, you'll get wood frogs. Another one is leopard frogs. There's actually several species in Indiana, but one is the northern leopard frog. There's that dorsolateral fold again. And then this just looks like another leopard frog, but this is a pickerel frog. And so I like to show you the difference between those. These actually live in seeps where water's kind of percolating out of a hillside and forming little places where they can lay the eggs and have tadpoles. Whereas these live in they're typical ephemeral wetland. But notice that these are kind of round. Oops. And these are like a square or a rectangle. And they also have this flash coloration on the pickerel frog. When a pickerel frog jumps, you get these bright flashes of yellow, which are disturbing to the predator as they try to focus on something to chomp on. And these guys don't have that.
They're both greenish.
Yeah, there's a fair amount of variability even in these two examples I'm giving you, but pickerel frogs can be greener than this, and leopard frogs can be grayer or browner than this. These guys, they were a species of special concern, and they were declining across the range, but then we figured out this was definitely one of the species where if you build it, they will come. So if you restore wetlands, like Eagle Marsh is a perfect example. There's millions of these, not literally, but there's a whole bunch of them out there, and they didn't used to be there. But if you put the wetlands back and the emergent wetlands, unless they're completely gone from the whole area, they come right back. The Hylidae are the tree frogs. Only some of them are actually arboreal. Our most common arboreal tree frog is the gray tree frog, but it turns out that there's two species. There's the eastern gray tree frog and Cope's gray tree frog, or Cope's tree frog. They look identical. In fact, I have this one set of pictures. This is the same frog. So people are trying to figure out what species is the green one, what species is the gray one. This one has a pattern, this one doesn't. Well, it's the same frog. And so the lesson is, you can't use those characters to tell these apart. So I'm not sure if I have this set up to play these recordings. No, sorry. But in the north of the state, they're the easterns. In the south, they're copes. And it's like right in Indianapolis are both of them. But the calls are actually a little bit different. You can go to the DNR webpage and they have all the calls and you can listen to them. You can also get trained to identify them based on their calls. There you go. So
You do have it set up. For some reason it's not on your.
what I mean by not set up is I don't have the speaker on.
Okay.
So you hear the two different calls there. One is more shrill, that's copes. The more casual one is the eastern. So you can actually listen and tell the difference. You cannot hold them and tell the difference. The only other way you can do it is by genotyping them, looking at the DNA, and then you know what you have.
Why was the frog that you have 4 pictures of, what were the color variations about?
Well, okay, so that lets me digress into something about like chameleons. You think about these frogs, or true chameleons, or American chameleons, the anoles like you see in Florida. Sometimes the same individual could be green or brown. That isn't about color matching, it's more about the state that the animal is in. And I think this might be the happiest. This is when he's feeling pretty good. But it might be that as they get cold, they turn brown. As they warm up, they're green. If they're dehydrated, they turn brown. So it's not about matching to the green background. It's more about how the frog is doing. If you look at something like a cephalopod, like a squid or a cuttlefish or something like that, they actually do blend to the background. And they can do a spectacularly good job, not only with color, but with texture. But these guys, they can't.